So I'd like to show essentially two prototypes. The good news of the day for me was the publication of a journal paper for the prototype we built last year that deals with design optimization on the blockchain. So it was published actually today, right before I joined the conference. And it's open access. You can actually read. Let me try and put it on the chat. Somehow this doesn't work. Anyway, if you search for framework for decentralized agricultural design, you'll find it. And also present, kind of show you how the prototype works. Sorry, I got confused with my files. Here you go. So this is a presentation, obviously, that I've used before that describes the prototype. And the story starts with a framework we built for the ICAD 2018 conference. It was the first paper we published on blockchain. And we were discussing various levels of integration between computer-aided design and blockchain. And then we proceeded in trying to establish a connection between BIM, building information modeling, and the blockchain. We were thinking of ideas where building information modeling works as a situation where both stakeholders and designers, architects have access to the files, but also contribute to the decision making. And beyond that, we essentially built tools where we have a plugin that uses Topologic and Grasshopper. Topologic is a library developed by my good colleague Wasim Jabi at Cardiff University. And we also developed the plugin from Grasshopper to be able to talk to Ganas for the Ethereum environment and for smart contracts on the Ethereum environment to deal with the information that Grasshopper would send. And this is a kind of representation of the workflow. You can read it on the paper as well, where you can essentially run two scenarios on the blockchain. One scenario that deals with collaboration, where a design problem gets encoded within Grasshopper, and then every time, say you have 100 people working on the problem, every time someone finds a new solution that is valuable, they publish it on IPFS, and through IPFS, every design agent gets the same files, right? So they find out what everybody else worked on and what is the current state of a good solution. And then each design agent synchronizes their file according to the latest best solution. We record all of these design solutions, and then all agents get paid proportionally in as to the value of the contribution. We can debate how you establish the value, but essentially through the collaborative scenario, you have a very accurate, very detailed understanding of who designed what within a larger project. If we see this as a competitive environment, the way this changes is that the design agents publish only the optimized value of the optimization problem they try to solve, and the hash of the IPFS file to the problem setter, to the owner essentially of the design problem. And the owner of the design problem can actually activate payments to those through the smart contract. Payments get activated to the person who has the best solution. And this happens through essentially an escrow account, right? So this only makes sense if the money are already deposited on a smart contract. And then from that, the design agent with the best solution gets paid. Now, this setup changes the way you would normally do architectural design, in the sense that normally you would try to establish trust between the agents, and you would need to develop certain legal responsibilities from that point of view. And what we're trying to do is we're trying to prototype solutions where the blockchain would, you would offload part of that responsibility on the blockchain. And then we didn't only do this, but essentially we prototyped it, right? So you see the Ganas, and we wrote an app that you can record. This is an app written in React, or rather, let me say that I didn't write this app, right? This was written for us by a company we work with. We mostly wrote part of the contracts. And essentially the app allows you to record hashes from IPFS, record all of the files that get sent, and it takes place also by connecting this through a blockchain plugin on Grasshopper. And you'll see here that essentially what I have inputted in is the address of the agent. So this is an Ethereum address, a private key because you need to sign the transaction, and an optimized value, which here I plugged it in by hand. And this gets packaged into a transaction as a JSON text file and gets sent to the blockchain you're working with. And immediately then that optimized value appears on the web page where you keep track, right? So this is just an interface for the smart contracts, and so on and so forth, right? If I go to the paper to try and show you this, so you'd understand. So this kind of is a schematic of the smart contract architecture, where you have essentially what we envisioned as a decentralized autonomous organization dealing with the decision-making approach. And then through these smart contracts, people are able to establish design solutions and get paid according to them. So we hope that this kind of setup or a similar setup can be used essentially in discussions where you translate design problems into smaller components that can be solved by a crowd actually of designers. The other thing that this introduces, which is really interesting, is that you can start building machine learning algorithms that would accept design problems to optimize for, and through the designer, that could be transparent completely, in the sense that you would not need to know whether what we call designer 1, 2, or 3 is a human or a machine essentially solving that problem. And the incentivization here to create those machines would be that the best IE or the best human would actually get paid from that point of view. So we have built essentially a system where you can put in machines and humans working together, and through the blockchain record who did what and get rewarded for it. Part of the prototypes were built by Avalon Consultants. I think I have them. So Colin and Andy, they work up here in Aberdeen, right? And I think they're excellent in terms of the service they provided, and we still collaborate in the prototypes we built at the moment. I'm going to stop the share now and ask if anybody has any questions for that prototype before I move on to Python.
Yeah, just a quick one for me. Was that prototype launched on a public or a private network?
When we tested it on a private network. So we haven't launched it. It's not live at the moment on a public network. The problem with that was that we could not, we would have to go through a special procedure to assign funds on the smart contract that would pay for design solutions just to test it on the public blockchain. Okay, I'll switch again and share my screen and show you. So that will go everything. I'll close this. You can find the prototype though, Dennis and everybody else. If you go to BIM blockchain optimization prototype, you will be able to get the Grasshopper extension, and you will be able to get all of the React API and all of the blockchain contracts we have. If you want to actually test this whole setup, you can do so by going to arcchain.cc, and if you go to output, if you go to BIM and blockchain first prototype installation process and follow through, you can download the code and everything else. And then this whole page acts as a to-do step-by-step process on testing this. And of course, we're happy to receive feedback from that point of view. But what I wanted to show is, I'll try and make this big so that you're able to see. So this is the same contract we stored strings on, right? And I pretend to be an IPFS hash here, which while you were watching the videos, I published on the Ropsten network. And essentially, what I wanted to do is I wanted to test reading from it using Python. And what I'll do now is switch to look at two Python scripts. To use this, you actually need to install Web3. I won't go into, installation. You can go to web3.readthedocs.io, right? And there are installation instructions there. If you have a Python 3 running environment, it's as easy as typing pip install web3. And after you have that installed, you essentially have a Python library installed on your machine that can be used to interact with the blockchain. Sorry, let me get back to the Python script. Are you able to see the letters, or shall I try to make them a little bit bigger?
I can see them fine. I'm not sure about others, but on my computer it's absolutely fine.
I'll try and make this full screen. So what we do is we need to import a couple of libraries on our script. So we import first JSON, which will allow us to work with JSON packages. These are essentially a specific format you need to write things in. From Web3, you import Web3, obviously. You will see some of my notes. A lot of times these refer to what I'm thinking at the moment, right? So changing to a testnet. I'm not using a node which I have installed here. I'm using an Infura node where I have an account. So you need to go to infura.io and establish an account, and then set that project up for Ropsten. Then the next line essentially establishes on Web3 that your provider will be your Web3 provider, so your node is going to be in Fura. If you have a local node, or if you're using any other kind of blockchain, for example, Ganas, you will need to change this so that it declares to the Python script where it needs to write. And you can also create an interface feedback where you say print Web3 is connected when you have a connection to the blockchain, right? And essentially this script now, what it does is it runs a transaction. I've created 2 test accounts. Let me take this. Firefox, sorry, not Firefox. I always get confused with the logo for MetaMask. MetaMask can hold various other accounts, right? At the moment, I have Robston Test Network, and then account A for the Construction Blockchain Consortium, and account B for the Construction Blockchain Consortium. I just named them SATs. When I have this account, I can copy and then go here and say, this is the account I want to work with. And here's now the dangerous part, and never do this with an account that actually really holds value for you. You go to account details and you say, I want to export the private key. So this is the private key for this account. And obviously this is what I'm doing at the moment, where I'm showing you this key is a no-no in terms of security, right? So never do that with an account that actually holds value for you. So what we're doing here is we're putting in the script directly hard-coded in the address of the account and the key to sign the transaction. I've noted here a potential execution fail, right? And this is a note for me to check specific documentation. Then we get the nonce, and this is the number used only once, right, from account A. Let me double check, yes. And then I am essentially building a transaction, right? And this is what a transaction looks like, right? So it has a nonce, it has a number. I want to insert the address. I want to take a second address, which is going to be yeah, okay, connected. I don't really care so much. Sorry. And put the second address here. And you see, I made a mistake at some point, so I said, be careful with typing, copying addresses. Then I say, this is the value I want you to send. Let me go with 0.2 Ether. If you don't specify a unit, it will send way, so it will be really small. I am setting up here the gas. It doesn't matter so much because I'm using a test network, right? But this would be really sensitive if you were running on a normal network. So I'm trying to keep time as well. And then the gas price I'm comfortable using. Chain ID says to the transaction which of the Ethereum networks to send this. If I put in 0, that's the main net, that's the real, the actual Ethereum blockchain. 1 is Robston, 2 and 3 and 4 are the other test networks. I sign this, and I'm going to save this file. And transaction.py, I'm going to change here. and I will type Python transaction.py, and something didn't work. So it says true, so it did connect to the blockchain, and I probably have an error somewhere. And let me try and find this. Line 153. I think I need to check my signatures from my point of view. Believe me though, it works. Let me show you another one where I am writing to running so that Python script, which is the second one here, essentially reads values from the blockchain. And these are the numbers I get here. And then when it tries to write, I get another problem with my account. So because I haven't defined it. You were not able to see the screen to see the code. Okay. Well, I have it uploaded on the CBC repository, so you will be able to get it there. Do you have any questions on the Python setup? So just to be clear, right? You can with web3.py you can create lots of connecting code between software that gets Python integration with the blockchain. One of the things we attempted to do with Revit, and I'm going to try and show this. Sorry, I'm taking some time because I need to change the private keys so that they're not visible. I'll start Dynamo directly. So what we have here is essentially a code block that builds the information for what you need for a transaction. So you can you give out the inferior URL. So this is the node I have on the mainnet. And actually, if I try to run it now, this will not work because this is a test account, and on the mainnet it doesn't have any ether. But essentially, you give the account, you give the private key. Again, be careful, right? If you send files, what you do with your private key. There are ways to actually sign a transaction locally, but you have to essentially build a file and read from that with Web3. The recipient of the transaction, so where you're sending everything, the amount, gas and gas price. So all of this is fed into a Python script. Sorry. Where essentially what we have is we receive, we run a sub-process where everything gets exported into a BAT file, and the BAT file executes the Python script that gets exported by this node essentially. So this node essentially exports two scripts. One is a BAT file, which is an auto execution file for Windows, and a Python script. And the Python script contains a transaction. So this is a really simple workaround for working between Dynamo and Web3 and the Ethereum blockchain. We are trying to build at the moment with Vasim, try to create a library that can be loaded onto Dynamo and can be used transparently without actually going through this whole brouhaha here, because let's face it, this is a hack, right? It's not sustainable, serious solution long term. So I hope that also answers the question with Ben had, whether you can easily integrate it to a front end with Python. Yes, if you have the knowledge to build a web page that would interface with the Python script, then it's not a problem to work through that. Perfect. Thank you. Thank you for this. Thank you for hosting me, and I look forward to the rest of the conference and all of the exciting discussions. And hopefully we can do this again in a much more upgraded, hopefully physical actually space. I mean, even though we're talking about digital spaces, I think actually, you know, going through a workshop in a physical space would be much more interesting.
Exactly.
Thank you so much, everybody, for your attention and your patience.